Good afternoon, everyone. So welcome to my YouTube channel, Math Sutra. So today we are going to see practice Set-VII on functions of bounded variation. So let's start today's session now. So question number 1 is, let f be a function of bounded variation for every x belongs to closed interval a, b. Which of the following statement is correct? So let's check it. Option number 1 is absolute value of fx is greater than absolute value of f at a plus bfx, variation function of f. Okay, at x. Second option is absolute value of x is less than equal to absolute value of f a plus bfx. Third option is absolute value of fx is less than absolute value of f plus total variation of f. It means variation of f. So D option is options B and C are correct. So let's check it. Okay. We have that you take any x belongs to closed interval a, b. Then we have b f a x is always less than b f a b, and this is always less than f x minus f p. Okay. So if I will combine these two functions, what I will get? I will get f x minus f p is less than, what is this? This is bfx. So this implies fx is less than, I will add and subtract fp. So this is fx minus fp plus f. So this is less than fx minus fp plus fp. Okay. But this is less than bfx. So this is less than bfx plus fp. So this implies fx less than equal to f a absolute value plus bfx. So this is correct. Okay. Now if we take these two, now we are taking now these two. So what we will get here? This will imply fx minus fp is less than bfab. Okay. Now again I will add and subtract. So this is, so this implies this is less than bfs. So I can write directly plus bfab. So this is true. So option number B and C are correct. Okay. B and C are correct. So option number D is correct. So let f be a function of bounded variation having intermediate value property, then which of the following statement is correct? F is differentiable. Second option is F is continuous. C, F is unbounded. D, none of the above. It is given that F is function of bounded variation. So F is always bounded. So option C cannot be correct. Either A is correct or B is correct or D is correct. So let's see. So first we will have to understand what is intermediate property. What is intermediate value property? Intermediate value property. What is that? Suppose F from closed interval a b to R is a function is said to have intermediate value property if for every C such that C is in between sorry is said to have intermediate value property if for every C such that C is in between we have for every sorry I'm writing here for every Y, let's say Y such that Y in between there exists C such that C is in between A and B and FC is equal to Y. So this is called intermediate value property. Okay. Every continuous function has this property. Okay. Every continuous function has this property. So remark every continuous function F from closed interval a b to R has intermediate value property. Okay. Second remark is that if F from closed interval F is a function closed interval a b such that F dash exists on a b. Okay. Then F dash as a derivative function from a b to R has intermediate value property. derivative function always has a intermediate property, intermediate value property. Whether f has not or whether f has, sorry, if f is a function such that derivative exists, then the derivative function will have intermediate value property. Okay. These are the results. Contains function has intermediate value property and derivative function has intermediate value property. Okay. Now this question. F is a function of bounded variation having intermediate value property. Which of the following statement is correct? If a function is function of bounded variation and it has an intermediate value property, then function becomes continuous. Okay. So I am writing it in remark. This is a standard result. So this is proof is long, so we are not going to prove this. If f is a function of bounded variation having intermediate value property, then f is continuous. Continuous. Okay. So in this question, which option is correct? Option number B is correct. Whether option number A is correct? Not. Option number A is not correct. Why? Because you see this function fx is equal to under root x on 0, 1. So this is monotone function. So this is function of bounded variation. And this is continuous. So it will have intermediate value property. It has IBP. IBP means intermediate value property. But this function f is not differentiable at 0. At 0. Okay. So option number A is not correct. So only option number B is correct. Okay. So f is a function of bounded variation such that derivative exists and f dash is also function of bounded variation. Then which of the following option is correct? F dash has intermediate value property. I have already told in remark second. If derivative function exists, it will always have an intermediate value property. So option number A is correct. Now it is given that f dash is function of bounded variation and it has intermediate value property. Then by question number 2, f dash will be continuous. So option number B is also correct. Now, if a function is such that its derivative function is continuous, then it is called continuously differentiable. Now, f is such function whose derivative is continuous. So obviously f is continuously differentiable. So A, B, C are correct. It means all the options are correct. Okay. Now, let f be a continuous function of bounded variation for any partition P of A. We write norm of P. It is called norm of P. Okay. Maximum length of subintervals. Okay. Which of the following statements is correct? The SPF, when we are taking norm tending to 0, the SPF will be less than variation of f. SPF will be greater than variation of f. If we are tending partition, norm of partition is equal to norm of partition tending to 0. If norm of partition tending to 0, then SPF is nothing but variation of f. None of the above. Okay. So let's check it. Okay. Okay. Let epsilon greater than 0. Then there exists a partition P is equal to P star such that SP star F is greater than B F A B minus epsilon by 2. Let's say it equation number 1. Okay. Now F close interval AB to R is continuous, and every continuous function is uniformly continuous on closed interval AB. So this implies is uniformly continuous. Okay. Uniformly continuous. Okay. So given there exists a delta greater than 0. We can take delta arbitrary small as we can, such that fx minus fy is less than epsilon by 4n for all xy belongs to closed interval AB with x minus y length is less than delta. Okay. Okay. Now take a partition P of AB such that norm of P is less than delta. Then, okay, put P1 is equal to P union P star. Then P1 is P containing P1 and P star is also containing P1. Therefore, we have SPF is less than SP1F and SP star F also less than SP1F. Okay. Because P1 is a superset, okay, of P and P star. Okay. Since contains at most two and contains n more points than P. Therefore, from let's say this equation number 2 and let's say this equation number 3. Then from equation 2, we have SP1F will be less than SPF plus 2n into epsilon upon 4n. Why this is happening? Because suppose you have this is P partition. So there is X naught, Y naught, Y1, Y2, okay, Ym is here. Now I am taking union with now P star, that is my P1. So X naught will come here, X1 will come here, X naught will be Y naught, X2 will be come here. Okay. Then if you have this point here, so you have two F Xi minus F X naught, Fy1 minus F1, and their norm is less than delta. The norm of partition of P1 will be less than delta. Okay. So then what will happen? Then what will be happen? The norm of P1 will be less than delta, because we are adding the points, these points, so they will be in between. Norm will be less than delta. Now by uniform continuity equation number 2, we will have this one. Okay. Because for each xi there will be two gaps. Suppose xi, this is my y0, this is my y1. So x1 is coming here. So I will take fx1 minus fy0. Okay. And I will take in SP1 f dash to quantity fy1 minus fx1. So for each xi, I have two options, that is adding in SP1. So it will be increased by this factor in SPF. Okay. So what is this? SPF plus epsilon by 2. Okay, so this implies SP1F is less than SPF plus epsilon by 2. So this is equation number 2. Now, what we have? We have from equation 4, SPF is greater than SP1F minus epsilon by 2. But SP1 is less than, what is this? SP star F minus epsilon by 2. And this is less than, by equation number 1, what is this? BF AB minus epsilon by 2. That is epsilon by 2. Strictly less than. So what we have? Now what is this? This implies SPF is less than BFAB minus epsilon. Okay. Okay. So this implies limit norm of P tending to 0, SPF is greater than equal to SPF AB minus epsilon. Okay. So epsilon greater than 0 is arbitrary. So what we have? We have limit norm of P tending to 0, SPF is greater than, let's say, equation number 5. Okay. But SPF is always less than BFAB. So this implies SP limit norm of P tending to 0, SPF is less than BFAB. From 5 and 6, we have limit norm of P tending to 0, SPF is equal to BFAB. So this is proof. So which option is correct? So option number C is correct. Now move to last question, 5th question. Let F be a continuous function of bounded variation. For any partition P, we write WPF is equal to summation I goes to n m capital Mi minus small mi, where capital Mi is supremum of F on this subinterval xi minus 1 to xi, and small mi is infimum of F on this subinterval xi minus 1 to xi close interval. Then which of the following condition is correct? Statement is correct. The norm of P tending to 0, WPF is strictly less than BFAB, variation of F on AB. Norm tending to 0, WPF is strictly greater than variation of F. C option is limit tending to limit of WPF, then norm is tending to 0 of partition is equal to variation of F, none of the above. Okay. So let's see. So you see that capital Mi is supremum and small mi is infimum. So we will have this one. This is less than capital Mi minus small mi, always. Okay. So this implies summation I goes to 1 to n fxi minus fxi minus 1 summation I goes to 1 to n mi minus small mi. What is this? This is nothing but equal to WPF. And this is, what is this? This is WPF and this is SPF. Okay. So this implies SPF is less than WPF. Okay. Okay. So we have this one. Okay, now we have this one. Now, so let's say this equation number 1. Okay. Now we have this interval. This is x0, this is x1, this is x2, x3, xn minus 1, and this is xn. This is my A, and this is B. Okay. So here is xi, here is xi minus 1, xi. Okay. And M, capital Mi is supremum and small mi is infimum. Okay. So there will be 2 points here. So there will be 2 points here. Some yi and yi dash. Okay, because function is continuous, such that fyi is equal to mi. Because continuous function always attain its supremum and infimum. Okay. So adding more points. So this will be these 2 points. Okay, difference. So we can find a partition. Therefore, we can find a partition P star such that P is contained in P star and WPF will be less than SP star F. Okay. Okay. So we will add these points. What will be the P star? So what will be the P star? We will add these points. So what is actually P star? P star is nothing but P union yi and yi star, sorry, dash yi is equal to mi and y star is equal to small mi for I goes to 1 to n. Okay. So this is a partition. So from so this is equation number 2. So from 1 and 2, what we have? From 1 and 2, we have SPF is less than WPF is less than SP star F. But this is a partition P star, so this will less than BF AB always. So this implies SPF now letting norm of P tending to 0, we get limit norm of P tending to 0, SPF is less than limit norm of P tending to 0, WPF is less than BFAB. Okay, but why last question number 4? This is nothing but the BFAB. This is nothing but BFAB. Okay. This is nothing but, so this implies limit WPF so this implies this is lower bound is this, upper bound is, it means what? By sandwich theorem we have this one. So which option is correct? Let's check it. So option number C is correct. Okay. So today's session up to this. If you have any problem related to this practice set, you can comment on my YouTube channel. Like, share, comment and subscribe my YouTube channel. Thank you very much for today's session. Thank you.